We've all been there, staring at an old machine, a car, even a phone, and asking that one question. Should I repair this thing again, or is it finally time to just replace it? Well, today, we're going to dive into the science of how to answer that question.
Just imagine you're running a factory, right? And your most important machine, the one that keeps everything moving, is just getting old. The repair bills are stacking up. It's not running like it used to. Your gut is screaming, we need a new one, but that's a huge investment. So how do you know for sure that you're making the right call and not just throwing money away?
Well, what if I told you there's a way to take the guesswork out of it? Seriously, there's a structured, data-driven method for finding that perfect moment to replace pretty much anything. It's an entire field of study called replacement analysis.
So what is it really? Think of replacement analysis as your financial toolkit. It's a framework designed to find the sweet spot, the most economical time to replace something. And the key here is that it's all about minimizing costs over the long term, not just what you're paying for a repair today.
Okay, so let's jump right into that classic repair or replace dilemma. We're going to start by looking at things that don't just suddenly break, but that slowly wear out over time. You see, as any piece of equipment gets older, a few things always happen. It gets less efficient, maybe it uses more power or produces less. The costs to operate it and maintain it just keep climbing, and at the exact same time, its resale value, what you could get for it, is dropping. Eventually, you hit this financial crossover point where it literally costs you more to keep the old thing than to buy a new one.
To make this super clear, let's look at a real example from the research this is based on. We've got this factory grinding machine, bought for $12,300. The big question is, which year is the absolute best year to replace it?
All right, let's get into the numbers. In its second year of operation, the average annual cost to own this machine is $6,425. Now that's not just repairs. That number includes the running costs plus that big initial purchase price, just averaged out over those first 2 years.
But now, watch this. Let's fast forward to year 6. The average annual cost has actually dropped a lot. It's all the way down to $3,225. So how is that possible? The machine is older, right? Well, it's because that big $12,300 purchase price is now being spread over 6 years instead of just 2, and that brings the average way, way down.
But here's the twist. By year 8, that trend reverses. The average annual cost starts creeping back up. It's now at $3,331. Why? Because even though the purchase cost is spread even thinner, those maintenance and repair bills are starting to skyrocket, and they're now so high that they're pulling the average cost back up with them.
And that little U-shaped curve in the costs? That's everything. It shows us the main idea for things that wear out slowly. We're not just trying to avoid repairs. We are literally hunting for the lowest point on that cost curve. We are looking for the sweet spot.
And there it is. For this specific machine, year 6 is the economic sweet spot. It's that magic moment when the average annual cost hits rock bottom. That means replacing it at the end of year 6 is, without a doubt, the smartest financial move you can make.
So that's the game plan for things that deteriorate, that get a little worse year after year. You track the total costs, you find the bottom of that curve, and bam, that's your signal.
But of course, that's not the only way things break, is it? Some things work perfectly 1 minute and are completely dead the next.
And this brings us to a totally different kind of problem: sudden failure. Think about things like light bulbs, or, as the research points out, the tiny resistors inside a computer. They don't get a little bit dimmer or a little bit slower. 1 second they work, the next they're just gone.
So this creates a whole new challenge. I mean, if you're running a massive warehouse with thousands of light bulbs, what do? Do you really wait for one to burn out, then send a guy up on a lift to change just that single bulb? Or is there a smarter way to do it?
This leads us to 2 totally different strategies for dealing with sudden failures. You can think of it as individual replacement versus group replacement. Okay, so the individual policy is what you'd expect. It's totally reactive. A thing breaks, you replace it. Simple. But the cost for each replacement can be really high when you factor in labor. On the other hand, the group policy is proactive. You decide to replace everything at a set time, say every 2 months, whether they've broken or not. It sounds wasteful, but because you're doing them all at once, the cost per item is way, way lower. And the research really nails this point. The group strategy is a game changer when you've got tons of identical items and you have a pretty good idea of when they're likely to start failing. It's all about playing the odds and getting those economies of scale.
So how do you actually choose between these two? Well, you already know the answer.
You don't guess. You let the numbers tell you what to do. So let's look at the data for a company managing 798 computer resistors.
First things first, we need a baseline. If the company just sticks with the reactive, individual policy, only replacing resistors when they fail, the math shows that their average monthly cost is going to be N17,100. Okay, remember that number.
Now let's see what happens if we go with the proactive group strategy. This chart tells the whole story. If we replace all 798 resistors every single month, the cost drops to under $16,000. Not bad. But look at what happens at the 2-month mark. The cost hits its absolute lowest point, $15,396. And if we wait longer, like 3 months, the cost goes back up because too many are failing before we get to them.
So the decision here is a total no-brainer. The data proves that proactively replacing all the resistors every 2 months is the cheapest way to go. And this isn't just pocket change. It works out to a savings of over N20,000 a year compared to just waiting for them to fail.
So, let's wrap this all up. What's the big takeaway here? This replacement mindset really boils down to 2 simple rules. For things that wear out slowly, you're on a mission to find the year with the lowest average annual cost. And for things that fail suddenly, you just have to do the math and see if a proactive group swap is cheaper than reacting one by one. But in both cases, the goal is exactly the same. It's all about minimizing the total cost of owning that thing.
And that's what this is all about. It's such a powerful way to shift these huge financial decisions from just a gut feeling into the world of actual data. So the last question I want to leave you with is this. What in your world, whether it's at your job or even just at home, could use its own replacement analysis?